Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro Electro Tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen. This is Retro Ernest of Retro Electro Tech, and here on the bench is a Pioneer SX950. I did an evaluation on this a while back. I had a lot of work ahead of it, so here I am again. So, you know, with all the boards out and I'm getting ready to go into a deep service on the controls. So anyways, oh, and by the way, of course I'm going to send the link to the customer as well, but the adhesive that holds in the dial glass decided to let go, but fortunately it was when the face here was on the bench, so the glass didn't have a long way to go, so it's all intact, thankfully. So anyways, and that happens sometimes. The adhesive on these, is weakened, just over the decades it does that. Sometimes the glass will fall out. So you got to be aware of that. Just careful when you're maneuvering a face plate, face panel. When you pull it off, just kind of be aware of that sometimes the weak adhesive will let go. Anyways, enough of that. So this came in initially with a noise complaint, and it was kind of a generalized noise complaint. The customer, I don't recall anyways whether he specified it was on one channel or the other. He just heard some noise that was present, put it that way. Some kind of like static or crackle, distortion, something like that. Okay, that's what I was able to gather. And of course, when I had a signal piped in it and was monitoring the outputs on the oscilloscope, I didn't notice any such noise. Not anything significant that supports what the customer was describing. Now, I'm not saying that he didn't hear what he described to me, but I didn't witness it. Now, yes, some problems are intermittent. Some problems are very, very intermittent, unfortunately. And as such, if that's the case here, and I just haven't, witnessed it yet, then, well, time will tell. I'm going to give it some time after I get through this phase, which is going to be the controls. And as I often say, I want to get through the controls first and make sure that I get these things squeaky clean, do the best job I can with the time and the budget that I have. And I always talk about that multi-flush cleaning and re-lubrication, as needed, where needed, and all that stuff. Okay, so I won't go into a lot of that as far as talking about it right now. And when I start getting into the actual work, then I might roll a little bit of footage here and there, give some of the newer people that are tuning in the opportunity to see what I'm talking about, as well as give the customer a little bit of video footage so he can kind of see what I'm doing here. So that being said, back to the noise. So I monitored things for quite some time, didn't witness any kind of obvious problem with any crackle, static, distortion. So as a lot of you know, an oscilloscope is a fairly sensitive instrument. So if there's anything audible going on, the oscilloscope is not going to have any problem picking that up. Now, the customer asked me when I let him know what was going on, whether or not I hooked it up to speakers, and I didn't. I haven't hooked it up to speakers yet. Of course, I always do when the time comes. When I get to that phase, I always do, and I will. But the reason why I don't really worry about that too much in the beginning, because like I just said, if there's anything that's present, any type of noise that's audible, especially something loud and scary as the customer was describing, it's definitely going to show up on the oscilloscope. No ifs, ands, or buts about it. And of course, I had a dummy load on this. Now, some might be saying, well, yeah, but what if you don't have a speaker load on it? Well, I tested it with a load, dummy load and all that stuff, and I will put a speaker load on it. And of course, with transistorized equipment, you don't necessarily have to have a load when you're performing certain types of tests, unless you're getting into power testing, of course, and you're really bringing up the volume and you're power testing it to see what it's putting out. Well, then, of course, I like to have a load on it. But anyways, but not a big deal. If there was anything going on, anything that's producing noise, anything that's audible, like I said, it's going to show up on the oscilloscope. Again, when I get to that phase, I will be testing it here in the shop on speakers and running it and dancing around the shop, playing music and all that stuff. But for now, I just want to remove from the equation any potential problems in the controls, because as I always say, and as a lot of you know, there's a lot of weird stuff that you can hear on account of dirty controls, intermittent controls, bad connections associated with the controls, whether we're talking external connection issues, i.e. a potentiometer, for example, or a switch that's not soldered to the board properly, or an internal connection issue, okay? Remember, there's contacts, obviously, inside potentiometers, inside switches, and if there's a problem, an internal issue going on from wear and tear, there's a defect, whatever, well, certainly you can have problems with noise, with intermittent behavior, the signal dropping in and out, all that. Switches, pots can cause a lot of noise problems, can cause a lot of issues with your signal dropping out, or kind of fading out, becoming diminished, crackle, static, weird crap like that, okay? So that's why I like to remove that from the equation right off the bat, especially when I don't see anything else that's really obvious, like something going on in the signal path with a bad cap, a faulty transistor, something like that, okay? Or some other connection issue going on that maybe I haven't ran across yet. So I want to start with the controls, get those squeaky cleaned, and I talk about a multi-flush cleaning often. I don't know if I already said that, but anyways, I'm not going to go into a lot of details on that. I'll roll footage when the time comes for some of the newer people, but otherwise, I just want to explain what my plan is initially, what I found during the preliminary evaluation, and to let the customer know that yes, I'll get it on speakers eventually, but if there is any kind of noise going on, I would have saw it on the scope for sure. And I spent some time, trust me, I was sitting there, with the signal piped in, checking the inputs, monitoring signal, looking at the scope, sitting there, watching it for a while, stepping away, doing some other work, going back, looking at it. Everything was rock solid and stable. The only thing that I noticed that I could recall, because this evaluation was a while back, is that when I was messing around with some of the controls initially, like I always do, to again verify whether or not any of the controls are producing noise when I start working them and turning the shafts of pots, clicking switches and all that. The only thing I noticed was I think there was some noise in the volume control initially, and I think a few other controls had a little bit of noise, nothing real alarming, but still I want to go through the controls in detail. That's my point. So let me go ahead and get to that. I'll explain what I'm going to start doing. So let me change the camera view. Alright, so starting with these push button switches that I have dangling about, I'm going to start by gaining access. Now these are the type of switches that are not open from the back. Now what I will point out that some people do is dribble a little bit of contact cleaner into these little slits here that run the length of these switches. They're not very wide, and I just really don't know how well you'll get contact cleaner worked down in there. I'm sure that some of it will work its way in. You might get the contacts a bit wet, and that's all well and good, but I'm a firm believer that the better you clean a control, the more time you're going to buy before controls will start acting up again. So some might argue that, and that's fine. You're free to choose the way you want to clean a control. That's okay. But in my experience, getting a really good multi-flush cleaning, solvent cleaning within these switches and potentiometers seems to produce better results as far as how long these controls will last in between cleanings. Now, you can try to dribble a little bit of contact cleaner in these little narrow slits, and again work these plungers, these shafts, whatever you want to call them, over and over again. That's all well and good, but again, I like to be able to get a forceful flushing of contact cleaner, really fill the cavity up with contact cleaner, flooded in other words, while I'm working them, and repeat that process several times. Of course, the condition of the switch is going to dictate how many flushings I will give a switch, and just how much I work it. I really make it a point to pay attention to which switches are the worst, and I'll give them extra attention. You know the old saying, right? The squeaky wheel gets the grease. Well, the problematic control gets a little bit more attention, or if it doesn't respond to that, then it gets replaced. Whatever the case, whatever turns out to be more economical, et cetera, et cetera. Availability of the control, all that stuff. I can go on and on about that. But what I like to do is, and also too, I'll mention, some people will also try to, dribble a little bit of contact cleaner in through the front and kind of see if they could push a little bit in. I've seen a few different methods out there, but really what I like to do is, you can see I have one of these little Archimedes drills, pin vise, Archimedes drill, whatever, it doesn't matter. And very carefully, and I mean very carefully, drill a little access hole all the way toward the back, as far back as I can go, without going all the way to the end, but just as far back in the center as possible. You got to make sure that the switch plunger is out, not in, because on some switches the body of that switch, the shuttle inside that, okay, so this, what I call a plunger or shaft, moves a contact carrier, a carrier with the contacts and all that, inside the cavity, or whatever, the body of the switch. On some switches, these shuttles or switch carriers, whatever, extend back quite a bit, especially when the plunger is pushed all the way back. So you want to make sure that's out when you drill your switch, and when you're drilling your hole. And when you're drilling that hole, you also got to move very slowly. You just do one little section at a time. Let me move my hand out of the way. So just one little section at a time. When you see a little bit of that, material, that whatever, phenolic or plastic, whatever you're drilling through, when you see those shavings starting to build up, or that dust, you brush it out, blow it out, whatever. And when you get to the end, finally, it's not just going to pop through all of a sudden, and you don't want to pop through all of a sudden. You'll meet up with some resistance. When you hit that little bit of resistance, you back off, clear out whatever else you can before you very gently, and I don't even, on this type of a drill, an Archimedes drill, I don't keep pumping it when I get to the end. I take over with my fingers and then just carefully twist it through very slowly, and then I don't really pop through. I just kind of ease my way through. And then all of a sudden, when I ease through, then I'll pull out kind of quick, so that if there's any residue that's hanging on to the bit, I'll pull that out and then blow out whatever. Now, some might say, well, but you might get a big shaving in there, and it might hinder the operation of the switch, or cause it to get gritty or seize up and all that. I've never, ever, ever seen that happen before. Now, maybe if you're pushing through and you just pop through and force a bunch of stuff in there, maybe that would cause some problems. But even if a little minute little particle or a little bit of a shaving, dust, whatever pops through, it's going to be so small that it's not going to cause any kind of obstruction or whatever. The inside of these switches don't necessarily have those type of tolerances, mechanical tolerances that are so darn tight that even a speck of dust or a little tiny shaving is going to bog them down and seize them up. Okay, so you got to kind of use a little common sense when you're thinking your way through this kind of stuff. All right, so that's what I'm trying to say. But on that note, choose your own method. Follow who you want to follow when it comes to utilizing these different procedures and so forth and so on, okay? If you don't feel comfortable doing it, don't do it. And if you do it, take responsibility for it. I'm not to blame if you screw something up, whatever. Be a grown man or a grown woman and deal with it. So don't blame other people. And I'm not trying to be nasty, but there are people on the internet who will scream, moan, whine about a lot of things. And when you're working on this old gear that is multiple decades old. This is stuff you didn't have to do years back. But now that multiple decades have passed and there's internal contacts that have, internally, they've tarnished up. They might have gotten a little oxidized, maybe a little condensation and moisture depending on how things were stored over the years. Maybe kind of worked its way in over time, depending on, again, what type of environment it was in, so forth and so on. Because remember, like I said, there are little tiny slits. You never know what's accumulated over time, but these switches definitely do have problems over time. No ifs, ands, or buts about it. Just because they're semi-sealed doesn't mean that they don't start having problems. So you do need to work them, and like I said, I like to flush them out with a lot of solvent, really flood them, and work them over and over and over and over and over and over again, and all that, because I'm trying to get those internal contacts to scrub while I'm flushing and getting a lot of fluid in there, a lot of solvent, and scrub and scrub. You see where I'm going with that? So that's why I do what I do. Now, if that doesn't make sense to you, or you want to go about it another way, please, by all means do. And then a lot of times after things dry out, after I've let them drip dry and time has gone by, then sometimes I'll add a little drop of fader lube in through the same hole that I drill in, the access hole. A little drop of fader lube in there, and let that kind of, I position the boards kind of slanted down. Let that kind of creep in there while I'm working the switches, just to get a little bit of lubrication in there. Not very much. I sometimes do, I sometimes don't. It just depends on how a switch kind of feels and all that. If they're nice and snappy and whatnot, and it doesn't seem like there's a lot of wear and tear going on, they're nice and snappy, then fine. So anyways, and usually a lot of these switches are just fine, because switches in this equipment aren't something that somebody is constantly playing around with like a volume control. Now, volume controls and tone controls that are adjusted a lot over the years, multiply that by almost 50 years or 40 something years of, especially if it was a unit that was used a lot and kind of lived a rough life, and those are the controls that you're going to usually see most of the wear and tear on. Be aware of that. Controls that are used a lot as a matter of course during the function of a unit, like selector switch, you're switching between your phono, your AM, FM, your auxiliary, all that stuff. You're switching them back and forth over the years, and the volume control, things like that. But controls that hardly ever get touched, usually you're not going to see mechanical wear and tear so much. What you are going to see, though, sometimes is just contacts getting tarnished over the years. So I know that was a long discourse on that, but I wanted to explain this thoroughly, especially to the newer people who are wondering, how all this works and why I'm doing what I'm doing, kind of the thought process behind it and all that. So there you go. Now, when I come back, I'm going to have these drilled out very carefully. So I'm going to take my time. I'm not going to do that. Maybe I'll do one on camera. I'll go ahead and do that, but certainly not the rest of them. And then I'll start the flushing process and the working process and all that. So there you go. Okay, so I'm going to start with this one here, and you can see just about where I am. And let me go ahead and just get my hole started, okay? And this is what I literally do. I just move through this slow. And you might be able to see around the edges of the drill bit. You can see the accumulation starting there, okay? So sometimes I have a little brush on the bench, but I just have my little blower, okay? So I'm just clearing that off, and then I'll go back at it again. I've already got a hole starting there. I'm moving nice and careful. I mean, I've done this a million times, so I do work a little bit faster. If you're new at it, work slower until you get the feel of things, okay? Because ultimately, I don't want to be dribbling this contact cleaner in through those little tiny slits and only getting a little bit in there. I want to really flood these controls out, okay? That's the name of my game. And others too. I'm not the only one who does this. This has been done for years and years and years and years, so it's nothing new, but I see the logic in doing it this way if you really want to buy the customer some time and do a thorough job. Like I said, when the controls are thoroughly serviced, they just have a tendency to last longer, okay? When you do a better job cleaning those contacts. Okay, now, it feels like I'm getting to the point, I think I hit a little bit of resistance. Let me check again. Okay, I did. So now what I'm going to do is very carefully, I'm just grabbing it by the collar here, the chuck, whatever, and I'm just going to turn it with my fingers while I apply a little light pressure. Okay, and I'm through right now. I could feel it. I could feel I just made it through. And now I'm going to rotate it the other way, and that's it. Okay? And you see that hole there? And I guarantee you, well, if you haven't, let me see how close I could zoom in here before it starts getting all blurry. Okay, so you can see I have a nice hole drilled in there, and here's the applicator of my contact cleaner. I can get it in there. See, it drops down in there real nice. Okay, see I got the angled applicator. You can go in with a straight one, doesn't matter. And then I could give it a good blast and flood it out. You can even see the contact cleaner coming up through those slits, so it's really flooding, it's coming out. And then, you know, I'll work it over and over and over and over and over and over again, okay, until the cows come home. So now I'm not going to work on it anymore. I'm going to end up flushing it again, but I want to get the other ones drilled out and hit them, you know, all kind of at one time, and I'll go back and forth and do my little, you know, do my little pattern over and over again and just work them and work them, okay? So that's what I'm talking about. So there you go. Okay, so I flipped the unit around and I did a multi-pass, multi-flush cleaning on all these switches and really worked them. So I focused on the internal connections involving these switchboards. Now I'm focusing on the external connections, the solder joints and these wire wrapped posts, okay? So I've talked about it before, but I will mention it again as far as a method that helps some, not all, because I think it just depends on the mind of the person. Let me zoom in on this board just a little bit before it gets blurry. And I've talked about the quadrant method, okay, and I'm not going to go into great detail on it because I really don't have to. It's fairly straightforward in that I'll oftentimes draw an imaginary line down the center here, a vertical line, a horizontal line across, and then focus in on the quadrants, especially when we're dealing with very busy boards with a vast population of solder joints. And in fact, if you want, you can even use, you know, like a physical card. This is the tag here, and you know, you could divvy up the board like that. It might help you to visually digest the population of solder joints a little bit easier. You can, you know, do something like that if it helps, okay? May not be necessary for some of you, but I'll bring my magnified light, you know, into play when I end up doing that. But for now, I'm not going to do that. So what I'm going to do is just go through and literally with a pointer, I will just go through with that little quadrant method and I'll touch the solder joints within a particular quadrant to start with. You know, whatever little pattern you want to employ, if you even want to employ a pattern. Okay, and here's this quadrant here. Okay, and I see a few solder joints right off the bat. There's one over here that's looking pretty thin. one over here that's looking pretty thin. It doesn't look real bad. It doesn't have actual cracks or really well-defined rings around it. It doesn't look like it's cratering or collapsing into the through hole or anything like that. But it does look a little bit on the thin side. It could certainly benefit from being touched up. Okay, and then I'll take another quadrant. This next quadrant here, this other lower quadrant, so left lower quadrant here, and same thing. I'll just touch the solder joints literally with the pencil, and just that way I'm making contact and I'm looking at it. Okay, that's what that assures, that I'm looking at it while the pencil's making contact. And again, that might not be necessary for you, and even for me, not so much, because this isn't a heavily populated board. And over here, on kind of in the middle of these two quadrants here, there's this solder joint here that's once again on the thin side. It could definitely benefit from being touched up. So I'll make note of that off to the side. And then I'll move on to the next quadrant and do the same thing. Check out all these solder joints. All right. And yeah, they're looking pretty good. Now for the, let me get a little more light over here, these wire posts. And since I'm on the subject, let me just go ahead. I'm going to pull the light down real quick. You're probably not going to be able to see that. Let me drop the exposure for you guys, because I know that that's kind of bright there. So just real quick, I'm just going to go over these wire wrapped posts. This one's kind of bent, but none of the soldering looks bad. I may touch up some of these posts just for good measure. Let me get this light out of here and kick the exposure back up. All right. Yeah, but all in all, everything's looking pretty good. There's about 3 solder joints that I'm going to touch up on this one. So let me back on out of here. So you get the point. I'm going to do the same with all these. Some are a piece of cake because they hardly have any solder joints. Check these traces out. These wire wrap posts look pretty good. The solder joints on this one are looking pretty good. This one I'm going to spend a little time on. I'm not going to do this on camera because, as you can see, there's much more wiring. There's much more solder, wire wrap posts is what I meant. And there's more solder joints on this one. So I'll just, after I'm done rolling footage, I'll go ahead and just do this on my own. And that's pretty much what I want to do is, the internal contacts of the switches and the external contacts and wiring and all that on these boards. That way I know I covered everything in pretty darn good measure. And then the next on my list here is going to be these boards here. I'm actually going to desolder these, just the potentiometers, and I'm going to see what access is like as far as gaining access, and I may go a little deeper on cleaning these pots. And of course, all these switches, I'm going to spray them out real good, and just work them and work them and work them and work them and work them, get my clickety-click thing going, and go from there. So when I come back, I'm going to have this board done as far as visual inspection, and then move on to these, get these desoldered. I'm going to inspect solder joints on these boards just the same. I won't show that on camera, the inspection of the solder joints, but that's what I'm going to do. I just wanted to demonstrate on these boards here, and just explain the quadrant method once again. That might prove helpful to some of you, so you can visibly digest what you're doing and be a little bit more thorough and hopefully not miss anything. So there you go. I'll be back in just a bit. Okay, so let's start getting these pots desoldered. Give them a better cleaning off the board. Okay, so here are the potentiometers, obviously pulled from the board. So my objective in pulling these is just to have a little bit more access to either spraying them out, if that's all I can do, Probably some of these controls, if I can get into them, then I'll use a cotton swab, a Q-tip, and some solvent, and clean the resistive tracks really good, thoroughly, and polish up the contacts, the wiper contacts, if I could, if it's not a bear to get into them. I'm not going to go into a lot of detail, but some of them were made to be more serviceable, just like the equipment, okay? Some of the potentiometers, depending on, you know, the make, the series of pots, you know, some of them were made to open up. They all have the tabs on them. You'll see the tabs, sometimes even after peeling back these tabs, and you know, you can only go so far. You just can't, you know, get these pieces apart and get the resistive tracks out and all that stuff. Some of them you can. So I don't really remember off the top of my head if I'm going to be able to do that with all these or any of these. If I can, I'll probably do the volume pot and, you know, go from there. From what I remember, and the reason why I say, you know, bring up the volume pot, from what I can remember, and I haven't gone back to the evaluation video because it's been a while, but I remember the volume control pot, for some reason in my memory, I remember that being the worst one. Now, I think that was even before I started rolling video footage, because I will often do that where, you know, I'm working on stuff and, you know, I don't always roll video footage right in that very moment, but I remember when I first started assessing these controls, the volume pot I'm pretty sure was the worst. It was producing a lot of noise initially, and then after I rotated the shaft a few times, kind of exercised it, it went away. And I was looking at the oscilloscope when I was doing that, and I did notice a lot of static and all that. I exercised it, rotated it around back and forth, just dry. I wasn't even injecting any contact cleaner, and that cleared it up enough, which is only, you know, a very temporary measure. You know, if you do that, you can clear them up initially, and then the problem will just keep coming back and all that until they get a good thorough servicing and all that. So I remember the volume control being the worst is the point. So that's why I'm thinking if I could get into the volume control, fine. But if I can't, having the pot off the board is kind of the next best step. Even though, you know, I can maneuver the board around and kind of tilt the board and get my hooked applicator, you know, because when these are mounted to the board, obviously, you know, the openings, these ports here are on the bottom, so you have to maneuver the board, and then you want to get your hooked applicator in there because you have other controls on the board, other things kind of in the way. So I use that hooked applicator to get, you know, up and over and down in the port and blast them out and work them. Okay, that's fine too, but if I can hold the control, even better, because then I could tilt it, you know, I can have access to the ports and I could tilt it kind of rearward, because ideally what I like to do is I like to try to keep as much of the solvent as I can from not, you know, wicking its way up into the bearing here, you know, that obviously, because at the factory they have the damping grease installed in there, which is why the potentiometer has that buttery feel to it. You know, you can feel that it's damped, okay? And the grease in this one is still pretty much intact, okay? Now, sometimes you just can't avoid it, depending on, you know, the level of cleaning you're doing. You're gonna wash out some of the grease there, and the control's gonna get kind of loose and all that, but sometimes that's the compromise, that's the price you pay for having to get the pot clean. It's either that or you're going to have a dirty control. So there's that compromise. But of course, if you can get it apart, then you can clean it real good. And if you want to put a little, you know, you can clean everything out, including the little bearing here or hub, whatever. Clean it out, and then you can apply some damping grease in there, and then all is good in the world. And you know, the customer has his nice damped, buttery filling control. But sometimes you just can't do that, okay? A lot of you know this, but you know, this is geared for some of you newer ones. So anyways, so if I can get in, fine. If not, I can at least hold it and kind of angle it, you know, where I want it, so that when I'm spraying it, I have the control position in such a way that not as much contact cleaner is getting up into there, and hopefully some of the damping grease will stay intact and it will still maintain its nice feel. If not, well, the pot's just going to be looser, that's all. So it is what it is. But having it out is better because I can really spray it out, hold it, in my gloved hand, and then, kind of tilt it when I'm firing contact cleaner up in there, flooding the control, and, let it kind of drain out and flush out crap from it if there's, debris and all that that's settled in over the decades, and, other, old lubricants and so forth, and get all that out, and at least do a bit more of a thorough job maneuvering the pod around. You can kind of do some maneuvering with the board, but remember, when you're moving the board around, the more you move these boards around, you run the potential of popping wires off the posts and all that, and if you don't see where a wire popped off, then that's kind of a pain in the butt, because then you have to track it down and try to figure out where a wire came from, and sometimes it's pretty obvious, but sometimes it isn't. So I'm just trying to cover some bases here, and that's about it. So I'm going to get into servicing these controls. I'm going to see if I could get into these ones, and some of these have the the shafts, as they extend through on the back of the carrier there, the disc that the resistive element is adhered to, attached to. Sometimes that shaft that runs through is press fit. It's kind of peened or press fit into place, and you just can't pull it apart. And sometimes there's other stuff like a little metal clip in there, a little wire clip, and sometimes they're just not really made to be pulled apart without going into major surgery, which in that case, that's not always going to be successful. You can end up damaging the control, and but even if it is, that's a lot of time, when it's just better at that point to try to source another control, either a new one that you can use as a workaround that's going to have the same shaft length and the same setup to accommodate the knob and all that stuff, which is sometimes kind of hard to find. Sometimes you can do it, they're out there, other aftermarket pots that will work in their place, sometimes not so much. And you just have to try to source one that somebody pulled off of a donor unit and whatever. And if they're asking, bigger money for the control, sometimes you just got to tell the customer, hey, we're going to have to spring for it. If not, well, there's not too much I can do, because it's going to also be expensive for me to go in there and try to do surgery on the control and pull it apart and grind down the little press fit area of shaft on the back and hopefully not damage anything. And then reassembling that, you have to, you would have to end up using a very, very fine bit, drilling down the center, threading the shaft, and then going from there and trying to reattach the shaft with a, reattach it to the carrier with a little washer and a little nut. And you're getting into some really detailed work and a lot of time, and that's if you could even get it back together again. Sometimes you can, sometimes you can't. That's just the way it goes. But to do that for a customer, if I had to do that to a control, it would not be cheap. There'd be a lot of time involved to really get it right. So there's that. So just more facts I'm throwing out. I know this is kind of a long topic that I'm getting into on this, but for those that are seeking this kind of information on what possibilities might be, in front of you, that's it. But at the very least, I'm going to try to get it open, see what I can do. And I don't know off the top of my head, from my memory, if these are the types I could get into. I'm kind of doubtful about it, but whatever. But at the very least, I got it off the board, and I can do a good thorough flushing and draining and flushing and all that. So there you go. So let me go ahead and get to that. Okay, and here we are. I have it opened up. I have at least the rear cover off. I'm not able to separate it, as you can see. And let me explain what I was talking about, so hopefully there's not too much glare, because of this metallic disc here. But anyways, so yeah, you got this disc here in the back. The shaft to the rear of the shaft extends through and is press fit in place, or peened over onto this. So if you're going to attempt it, you'd have to grind this down. Sometimes it works out, sometimes it doesn't, whatever. But don't forget there's reassembly. Now, if you were to do that and you're able to get these halves separated and all that jazz, sometimes on these, after getting this section of disc separated, this half separated, and you get this other cover off, sometimes down in there, and it's not easy to get to, is a little a wire clip that holds the shaft in, locks the shaft in place as well. So it just depends on, again, the type of pot and all that. So anyways, but also too, during reassembly, in order to get the shaft back in, get everything all situated, you'd have to you'd have to use a drill press and a very small bit, because as the shaft passes through, the rear of the shaft, it thins down, it flattens out. I think the rear section of the shaft is actually flat and rectangular, and there's not a lot of meat on that rear of the shaft. So that's why you'd have to drill a very small hole down its center, just a little bit, and then thread it, and then go from there and see if you can get a little tiny screw and a washer and all that, and lock everything in place and to hold that shaft in there. So it could be done with the right know-how and a good drill press and the right bits and the ability to thread a hole that small and all that stuff. It can be done, especially if you're a machinist type of guy or gal. Yeah, it's not impossible, but is it worth it? Whatever. Like I said, it's better just to source a replacement than try to do major surgery and get very creative with the getting everything reinstalled and all that stuff. But anyways, there you go. So I'm going to go ahead and just get these cleaned out. And like I said, it wasn't a waste of time getting them off the board. I like to have them off the board if I can anyway. So okay, so I'm all done cleaning up the potentiometers. Obviously I didn't want to roll footage on that, just spraying them out and working them. But after doing that though, I always like to go through and test the pots, run them through their ranges. And what I mean by run them through their ranges is, for example, a 100K pot, 100K ohms, 50K ohms, run them through their range. And we're going to do that on a meter, on an analog meter, a meter with a needle. And I'm going to turn the attention over to the analog meter in just a moment and explain what I'm going to get into. But first, the way I go about it, and I'm going to just show the volume pot, because remember, the volume pot was the one that I feel had the most ugliness in terms of being dirty and all that initially anyways. And so this is the volume pot. Never mind the loudness tap over here, but what we're going to do is from end to end, and you can see on the back it's a 50K pot, 50K. Now we want to go end to end, just like a fixed resistor. When you measure a resistor, you go end to end to get the total resistance of that resistor. So same thing here. These here are end to end, and this is the wiper contact, the movable contact inside. So initially, being that this is a stereo pot, I like to check end to end on both halves to see if they're fairly equal as far as symmetrical with each other in terms of their resistance, or if one half of the stereo pot has drifted more than the other. So I just want to see if there's an imbalance there. Usually there's a little bit of an imbalance, but nothing that you're going to audibly hear. Okay, most people anyways are not going to be able to audibly hear the little changes in tolerance over time. And sometimes they're even that way from the factory. Just like any resistor, these have a tolerance. Okay, so let me go ahead and switch on over to the meter. And what I'm going to do first, I'm going to go end to end on both halves. Okay, and we want to see, well, I'll go ahead and tell you what we want to see, but we're going to start with that. Okay, so on this meter, you remember that the volume pot is a 50K, 50,000 ohms. So both halves, okay? And, well, each half is 50K. So, this is for the beginners, guys, so that's why I'm explaining it like this. So each half is 50K. And that's what we want to see. So when I read across those terminals that I showed you, that I'm looking for the needle to reach 50, because I have the meter over here set to times 1K, okay, so times 1,000, so 50 times 1,000 is what? 50,000, and we have a 50K pot. So there you go, Mathematics 101. So I'm going to read across, once again, the first half, okay, and I have the camera positioned fairly in line with that meter, so there's not going to be too much error as far as, you know, viewing that needle. But okay, you can see we're sitting right there at just about, just a little bit, just a hair above 50, okay, which, yeah, good enough. Now when I clip onto the other half of this potentiometer, we're going to see how much of a difference there is between the two halves. There might be a little bit, and that's okay. Nothing to get all freaked out about, and you know. But actually, if you notice, both halves end to end are pretty much right on par with each other. That's a little bit above 50K as well, so not bad. Now the next thing I want to show you is that I'm going to be moving one of the let me see, one of the probes here. And remember, we were clipped on end to end. Now I'm going to move this one that I just showed you to the center, which is our wiper, and you know, on the same half that I left off on. Okay, and you notice I'm all the way down at 0 there. Now watch when I bring up the volume. Now I'm going to turn the, it's going to be a little blurry when I hold it up, but you got the point. I'm going to turn the volume knob now, okay? And I'm just going to bring that up and look at that smooth transition there, okay? You know, back to 50K, and then back down. I'm rotating it as smooth as I could, all right? And now I'm just going to speed it up a bit. Okay, so down, up, down, up. Now let me go back down. Now let me do that same thing with the other half of the potentiometer. Okay. So I'm clipped on from wiper to one end, and same thing, I'm bringing it up. Nice and smooth. Okay, back down, back up, back down, back up. And that's what we want to see. We want to see that smooth transition of the needle. So I'm going to do something with the knob, and I'm going to sort of exaggerate what you would probably see if there was some problems, if the potentiometer was really dirty along the resistive track, or the wiper was really dirty, oxidized, tarnished, and it just wasn't making good contact, especially in certain spots. As you're bringing up the pot, you might experience kind of a lag there, or it might start doing something like this, and I'm trying to just get the needle to act really jittery, and then sometimes it would just completely drop out. You'll start to go up, and if it hits a dead spot, boom, it'll just drop back down. It's not going to go all the way through its range, 50K down to 0, 0 to 50K, nice and smooth like you see it doing there. Which is why you want to use an analog meter, because you can see that, you can physically see that needle moving up and down, you know, up and down. And if there's any dirty spots, the needle will get kind of jittery and start, you know, doing this number, getting jittery, or it'll just drop out altogether, okay? So there you go, and that's what I'm looking for when I'm going through these pots after I clean them, especially when I have them out and I just want to clip onto them and give them a once over before I continue on and solder them back in. Because if I wasn't getting a favorable reading, well, I would try to, you know, hit them again and again until it gets to the point where I said, you know, enough is enough. This pot isn't responding favorably. It's not going to respond favorably to a cleaning, and I'm just going to have to replace it. But in this case, these pots are all responding favorably. They're looking good on the meter as I'm combing them through their ranges, and there you go. And otherwise, those solder joints that I pointed out when I was going through the inspection and looking at the solder joints, I got those all touched up. So what I'm going to do now is get the pots soldered back to the boards, get the boards reinstalled, And then when I come back, I'm going to start checking voltages, the critical voltages in this unit. Again, I did that in the very beginning. I spot checked some voltages, but I'm going to go a little bit deeper, assure that all the voltages are sitting pretty much where they should be sitting. I'll show some of that on camera. And otherwise, if everything's looking good, then I'm going to go into audio testing and monitoring. Oh, and one more thing I'm going to do, especially on the amplifier boards, I'm going to go through the amplifier boards real quick and just make sure that there's no known problematic transistors on board. Okay, again, I've mentioned this in other videos that I'm not a walking transistor encyclopedia, so I'm not necessarily going to start jotting down numbers and going to the internet and looking for people who have posted lists of known problematic transistors. I know some of them, but again, I'm just going to see what I spot right off the bat. Just make sure that there's nothing that I'm aware of anyways that's known to be problematic. Because if so, I'll probably end up changing them out. I do know that there are some of those light blue Sanyo capacitors that are known to be problematic as well. Not too many of them, but there's a couple, so I might end up changing those out, of course. I'll get with the customer on that, see if he wants me to do that, because the budget is pretty limited on this overall. But if he wants me to go through and do a little work on the amp boards and just at least take care of the Sanyo caps that are on the amp boards, and I'll go ahead and do that. And just go through and do some quick spot checking here and there, intolerance checking of a few things, and that's about it. But otherwise, I'm going to want to get into some audio testing after that and just monitor things and make sure this thing is going to remain stable, nice and quiet, that it's not going to make any scary noises or crackles and pops and all that crap. So let me go ahead and get to it. Okay, so everything's squared away with the controls. I jumped ahead a little bit and said that when I came back that I was going to be powering this thing up again and checking voltages in more detail, which I'm going to do, but later on. What I jumped ahead on was I wanted to get the amplifier section pulled in as budget-friendly of a manner as possible, meaning I'm not going to disconnect wires and from all the posts and pull the board out and do all that. But I've got good enough access to what I need to have access to, and I had mentioned earlier that there's these light blue Sanyo caps that are known to be problematic. They're documented to be problematic. Not that these ones necessarily are at this point, at least not to the point where they're causing problems as far as I know. Now, as I said, I did an evaluation. I had signal piped in it. I was monitoring things on the scope for quite a while, and I didn't notice any problems, as I already explained before. But that doesn't mean that down the road there might not be something that crops up, or if there was a very intermittent problem that the customer was talking about, because he did say he heard some noise and some weird sounds, I think some crackling, some whatever, staticky sounds, something like that, which I didn't experience. But what I wanted to mention is that I said too that I was going to look at the transistors here. Now again, I know that everything's working, that the transistors are doing what they're supposed to be doing, amplifying signal and so forth. But I did discover that the differential pairs on each channel, of course, are of the 2SA725 variety, which are also documented to be problematic. So they have the tendency to get kind of crackly, sizzly, and poppy and all that. And again, not that I experienced that, but maybe the customer did. But if not now, very good chance that in the future, because these are known to be problematic transistors, that they will start exhibiting some problems if they're not already, and I just didn't witness it yet. So I'm going to get these out of here and match up some transistors, probably some KSA992s or something like that. And what I want to mention about matching the differential pairs, and a lot of you know this, is that the more crucial parameter to get squared away is your VBE matching, your base emitter voltage, get that all squared away. And also too, gain matching, but as I mentioned before, it's the VBE matching that's most important with your diff pairs here. And I'm going to do both, of course, VBE and gain matching. You can see if I zoom in, bear with me here while I try to get in here a little closer. So you can see the transistors here. I'm not going to zoom in on the on the identifiers and all that. They are, you know, 2SA725s, but you can see the blue dots there indicating that they're matched at the factory and all that. And here's our light blue Sanyo caps. I think one of them is a 1 mic at 25 volts and the other one is like a 2.2 at 25 volts. So I'm going to get these all squared away. I'll probably use some film caps in here and again some KSA 992s. But one of the things I want to do before I even get started there, it's really dirty on the top side here, as I mentioned, or maybe I didn't mention that. A lot of fuzz, dirt, and all that. So I'm going to vacuum things out, get this all cleaned up here on the top side, and then get those parts in after I get the matching done on the transistors, and you know, I'll get that all squared away. And in addition, you can see the way I have this arranged. I'll drop this down a little bit more here. Let me see. Yeah, good enough. So you can see the way I have this arranged. I've got access to the back, of course. I'll go ahead and check solder joints while I'm at it, do a little inspection in here while I'm popping in the new parts. And yeah, everything's looking good there. Let me set this here carefully. Spin this back around. Okay, all right. So anyways, so that's the plan of attack right now. So being that I discovered I have a little bit more to do on the top side here with transistors and going into a little more of a thorough inspection on the solder joints on the back of the board, get these amp channels recapped. I'm going to go ahead and come back in the next video with all of these in place, the top side cleaned up. Oh, and also too, I am going to, of course, check out the relay, clean the relay contacts. I always do that as a matter of course, at the very least clean them. If I needed to replace a relay, of course I would do that. So that's what I'm going to do in the next video, is have that all squared away and then go into some testing of voltages. Like I said, I was going to do on camera, checking in a little bit more detail all the crucial voltages and a little bit of this, that, set the bias and all that stuff. All of the usual stuff as I'm getting ready to, you know, send a unit home, all the finishing touches. All right, so I'm going to do that. So I'll say that for the next video and the audio testing and whatnot. So otherwise, guys, I'm going to end it here. And as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.